I'm Selby Buckley, and today we're going to be giving you a presentation on the effects of ocean acidification. Send it. We truly live on a blue planet. The ocean is the largest and most complex habitat on Earth, covering 71% of the Earth's surface. The ocean is essential in the removal of carbon from the atmosphere and is instrumental in maintaining the stability of the Earth's surface temperature. Through the process known as the biological pump, carbon is removed from the atmosphere and stored at the bottom of the ocean, turning the ocean into a carbon reservoir. This essential process is affected negatively by ocean acidification in several ways. The most prominent effect acidification has is its effect on the various species of micro and zooplankton that inhabit the surface waters of the ocean around the world. These organisms create protective shells using bicarbonate from the water to create calcium carbonate, just like a snail does. A more acidic ocean impedes this process, directly affecting the base of the ocean's ecosystem as well as the mechanism of the biological pump. Similar acidification rates to today's acidification rate occurred during the Permian Triassic extinction event that killed 90% of all marine life alive at the time. Acidification's effect forms a positive feedback loop. As the Earth warms and the oceans acidify, the biological pump weakens, which means more carbon that's released in the atmosphere will stay in the atmosphere, which will compound the heating effect. Thank you.
Thank you. The primary cause of ocean acidification is the release of atmospheric CO2 from human activities. The only known realistic mitigation option on a global scale is to limit future atmospheric CO2 levels. Although alternatives don't make much of an impact, there are a few things we could do. Monitoring and regulating localized sources of acidification. Monitoring and regulating localized sources of acidification from runoff and pollutants such as fertilizers. Developing strategies keeping in mind the socio-economic impact on natural resources and human communities. Strengthening monitoring abilities, more field and lab studies. Understanding the relationship with climate change and the cost additions and mitigations. Environmental laboratories in Monaco study the effects of ocean acidification. The 3-day event focused on the impacts ocean acidification could have in Latin America, a region where the sea is a key source of food and revenue. A member of the OAIRUG, Dan Lofley, said, "The effects of human activities on the environment are already noticeable, and if greenhouse gas emissions continue to increase at the current rate, grave consequences are to be expected for the marine environment and for human populations depending on it." Okay, one more time. Ocean acidification, a series of changes in ocean chemistry, can impact the capacity of many organisms to grow shells and bones. In result, as organisms are more sensitive in early life stages, some would not survive to adulthood, and some species populations could decrease, such as oysters. Food supply from the ocean would become 0 to none. Adapting would consist of finding food only on land, but still releasing atmospheric CO2.
Ocean acidification affects every marine organism differently. For example, food chains will be disrupted. Brittle stars, which are essential food for the flatfish, will see drastic population decline as a result of ocean acidification. It causes significant problems to marine life that form calcium carbonated shales. It causes significant problems to marine life that form calcium carbonated shells or skeletons. Studies show that ocean acidification stunts the growth of young sea urchins by thinning and deforming their shells. Surprisingly, ocean acidification is not bad for every sea life organism. Jellyfish and algae adapt better than most species. Therefore, they are dominating over the weaker habitats.
Carbon dioxide is a big problem since it has become very abundant in our atmosphere. It doesn't fully stay in our atmosphere. The ocean absorbs approximately about 50% of the carbon dioxide that is in the air. Scientists thought that this was something positive since it helps us remove the problematic greenhouse gas emissions from the air. However, The increase of carbon dioxide has affected the ocean water negatively. The increasing of carbon dioxide in the atmosphere means that the ocean is going to absorb more carbon dioxide, which changes the chemistry of the seawater. The pH scale is used in order to measure the acidity of the ocean. The pH scale measures how acidic or basic a substance is, and it ranges from 0 to 14. The higher the number, the more basic the substance is. From pre-industrial time, the pH level from the ocean has fallen by about 0.11 pH units. Since the pH decreased, it means the ocean is more acidic. Computer model forecasts have predicted that there is a drop 0.3 to 0.4 pH units more by the end of the century if we continue to burn fossil fuels as
Thanks for watching our video. We hope you thought it was informative. This video was created by Tobin Buckley, Vanessa Gonzalez, Kaylisha Ward, and Frida Ng.